Yeah, so my name is Christian Wolf. Some of you know me, some of you don't. I'm program manager for performance and reliability in Dynamics AX, also called Dynamics 365, also called CDM. There's many names for the same thing, right? It's all very confusing right now. And I'm going to talk to you today about AX7 and how it performs. And we go a little bit through yeah, some general basic architecture stuff. If you are in already for a while, you have probably seen that. And we just see, maybe you can get something new out of it. And then we go a little more in detail of what our internal performance tests saying, and then what are the slow things we see in the market right now. And so basically what is slow and what are we doing about it, obviously. And then we talk a little bit about features. And then I walk you through, OK, troubleshooting performance in the AX7. So because it may look like an AX7 after everything is like a platform as a service solution, it may look like, well, there's nothing I can do, right? But there's a hell of a lot you can do. And I will walk you through all these features. After that, we will go a little bit through the perf testing story, how you can create your own perf tests. You have like 2 little bit longer demos. And then we open it for Q&A. So I guess you have all read that already, like, and all of that, right? Yeah, all of that. So skip that. That's the agenda I just talked about. So first we talk a little bit about Dynamics AX7 scalability, how the architecture is built, the roadmap. There's a tiny little bit repeats between this session and my sessions tomorrow. But I think you will pick up new things from all the sessions. Then troubleshooting, load testing. All right, let's talk about scalability. So understanding the architecture of a product is basically, number one, to understand how it scales or not scales. Then if we look at the AX7 and its general architecture, let's look first at the old side, AX 2012 or before that. So there's 2 key changes. Anyone wants to give a shot? What's the 2 most important changes? And what's the implications? Yeah, right on. So, OK. Why is that such a big thing? Because if I remove RPC, so the answer is, well, there's no more RPC, there's no more WCF. Well, we have still SOAP services and OData services called in AX7. That's our integration story. But the key thing is, if I take this middle layer out and replace it with HTTP request, what do I need to do? Well, any one of you ever took a trace with trace parser? Like, no? Yeah. What have you seen? Hundreds of RPC calls, sometimes thousands. Well, now there's 1 HTTP request per interaction. So that's the work we had to do, basically. And I will show you how to find these in traces. When you look at AX7 traces, I show you how to look at this and how to understand, oh, now the client is talking with the server, basically. Now we have an HTTP request. So we took this middle layer out and did massive optimizations in regards to HTTP requests. That gives AX7 scalability 1 benefit. So what was the average latency you had to have so the client-server connection was fun for the end user in AX 2012? Less than 5 milliseconds for sure. Well, now it's about 150 to 200 milliseconds you easily can have between your browser session and the server. It has another impact on scalability, though. So what we also did, we removed this whole client thing, right? This whole AX32.exe is gone. And we replaced it with a browser. And this browser, basically, this browser-based solution is using jQuery and JSON to communicate to the AOS. And for that, it's using the interaction service. So there's a layer on the AOS. It's called the interaction service. Then the AOS is just a DLL, and this DLL is loaded in the IIS. So that gives us a lot of scalability. But that also implies a problem. And that also will tell you why we can't compare AX7 and AX 2012 really. I mean, if you remove the client, you still need to keep the form state somewhere, right? So we keep the form state now on the IIS. And that basically leads to that you pay all the cost, which was before on many, many clients or many, many terminal services. That's all now on the server. So, and through that, the AOS is a little more heavyweight as it used to be in the past. So if you think of AX 2012, if you have a pretty beefy AOS with 16 core and you do a very even workload of maybe just sales orders and purchase orders, you could probably load like 200 users, 250 users on one AOS. Doesn't work like that in AX7. We have like maybe 50 users on an AOS on an average, so we need to be a little more cautious. It has a few cool benefits. If you ever ran a benchmark on AX 2012, then you used the businessconnector.net for doing that. And then you had to simulate the UI, and you had to simulate all the RPC calls, and it was actually not a real realistic thing. Now in AX7, if you run a benchmark, which we will show a little bit of demo how at least the entry point works, then you actually get a pretty realistic result because all the forms live anywhere on the server. So all the stuff the forms do, you actually execute. You just skip the web UI, right? So let's talk a little bit about the architecture. So how AX scales is basically we have the Azure Traffic Manager, and then from any kind of client we get a request to this Azure Traffic Manager, also called ARR, Azure Request Routing, or the Azure Load Balancer. We basically point to multiple VMs. And each VM hosts like an AOS. These are something like if you know the Azure's machine sizes, these are, I think, D13 V2s or D12 V2s. I think D13, the 8-core one, basically, with lots and lots of memory. And then the high availability is basically managed, and the scalability is like an N+1 mechanism. So, and then in the backend, we have the AX database, the entity store database, and we have also the option of adding a read-only secondary, which is essentially doing some things like you can offload certain workloads, and we talk a little more about that on a future slide. And then you have the management reporter, which is another database. And the AX database can be basically the high availability is managed and scalability. So we have like an always-on mirror, and then you have a geo-separated mirror. Whereas for the geo mirror, you basically, that's an extra thing you need to add to your license. That's not coming just for free, I guess, as far as I know. So let's talk a little bit about features. So these are things there were many things we did under the hood, obviously, but I figured I'd point out rather a few more features, what we did in the last updates in general. So let's talk about the forms features. So when you open a form, and then you go to a detail form from the list page, there's a thing called copy caller query, which is copying the query basically along. So, and then you have a few buttons at the base of the form, and you can click between the records, right? So this copy caller query essentially helps you to navigate in the detail form. Now, this was very expensive, and we just spent quite some cycle on optimizing that. So that was one tuning part we did. That's something under the hood you will barely notice. It's just working for you. Then we noticed that we do lots and lots and lots of outer joins and passive and delayed loading. So whenever we have a delayed loading, we actually only add the data source to the form if it's necessary. Also something under the hood, you will not really notice much of that. Fast grid uptake. Many of the things we do after we go more and more in the direction of be a service actually are targeted on benefit all performance. So things you don't even need to do anything. You just get the benefit. The fast grid uptake, once we ship basically before update 2, the grids were a little slow. But yeah, we spent quite some cycle on fixing that. Then we implemented the read-only secondary. And that's actually a cool story, because in AX 2012, when you could try to create some sort of read-only secondary by yourself, right? If you use the right SQL backup mechanism, but it was never really working great. Now it's basically out of the box. You can have a read-only secondary, and basically what happens is one of these always-on mirrors, and we just synchronize our data there, and then we build all the tile cache. So if you go to the workspaces and you just see all these tiles, the cache is basically built up from the read-only secondary. So you just access that, and then the query-based reports without XDS is what we also load from there. At the bottom, let me jump to the very bottom. There's the entity store. The entity store is also basically a sync from the AX database. So we think about retiring the entity store and move all things like tile cache, read-only secondary things. We move all of that to the entity store, so that might be the next big move. Because on the entity store, it's not a read-only database. We can, obviously, the name implies, right? If I synchronize into it, I can load all kind of data into it, so I can write on it. And I can have a tempdb, and with that I could, for example, enable all the data source queries, all the data classes and data provider reports. I could enable them on the entity store, and I can do a few other things like display and edit methods. I can all create and basically get the data from the entity store. So ultimately, the long-term goal would be to minimize the read access on the AX database as much as possible. Some things like display methods, obviously, or preview pens would need a read-only secondary because the data needs to be in sync, it needs to be just in time. So there's some design considerations we have around that. And then we have a bunch of framework features. Some of them are, I think, these are things you can actually all use. So run async. When we post our expenses, basically, the line processing happens asynchronous nowadays. So run async, if you use the Sys operations framework in the past, it was a little more complex to use. With run async, you can just run any operation asynchronous, very simple with just one call. So it's kind of like an API to run things asynchronously and gain more performance. So that's something you can use in your coding practice. Then throttling of async operations. Well, if you do a lot of things asynchronously, it happens that you get actually, maybe sometimes overload your system because you do so many things asynchronously that you don't know what you actually do to your system in this moment, right? If you have hundreds of users posting and things happen and they spawn off multiple threads, and suddenly you get hundreds of threads, and well, then suddenly your AOS is overloaded. And then after the AOS this is like one new cool thing we work on right now. We try to put the AOS on Service Fabric, and then once we're on Service Fabric, we can have something like auto-scaling in the middle tier. So then I don't care. I just add a few more AOS on a need basis, and I remove them again if I don't need them anymore. But right now, it's pretty static. So the AOS you have in your subscription, that's the AOS you have, right? If it's 4, it's 4. So anyway, we throttle down async operations. So if you notice that the AOS or the SQL CPU gets into the 70 or 80%, we just throttle that down. And you can select that in the user interface of AX, and in the system administration, you can define to what you want to throttle that. So whenever we detect the AOS or the SQL CPU gets into the 80%, we start throttling it down. What the effect of throttling is, we just start processing things sequential instead of in parallel. So that's the only effect. Then asynchronous loading of fact boxes. That's something you need to enable. You just need to go in the form in the parameters of the fact box and set it to be loaded remote. And we have the option to use hackathon tables. So hackathon, that's SQL in-memory processing. So the cool thing about that is so you can basically set the schema. So there's two settings in the table. You set the table as tempdb, and then schema only, or in memory and schema only. And then basically this table gets created as a hackathon table. So there's a few problems with that. We don't use it much in our standard code because it doesn't really work super well with the AX, with the regular AX tables. But if you have a customization with a little bit like where you exactly know which tables this touches, right? It's a feature we enabled and we had no time to uptake it in our own features. Essentially, that's what happened. So, but you can start in your coding with AX7, you can know about that, and you can say, okay, I set this table up as a schema-only table and then as an in-memory table. And boom, you have a hackathon table, and you can do very fast inserts and very fast updates on the table. So it's a little bit something like the TempDB, a good way for massaging data and for basically doing things like that. Well, tooling, this is where we have most of the demos for, so don't talk too much about it. Essentially, we have telemetries, and we will see spoils of the telemetry very shortly. I can tell at almost any point in time how many slow forms I have, which forms are slow. Technically, I can find out the tenant and things like that. I cannot see any usernames. I cannot see any email addresses or social security numbers. All of that gets removed from our telemetry proactively. But I can see, hey, what is currently the slowest form in the market? And actually, I will show you. Then we have a generator, and then we build a system on top of our telemetry, which makes the troubleshooting even easier. And this system is exposed to you. And this is what I also will show you. So then the code gen for single and multi-user testing, that's basically one of the demos. So you can just record something with Task Recorder, and you can create a little file from that. And then you basically can create a single and a multi-user test. Creating a multi-user test is quite a few steps. That would probably explode the part of this presentation. But I show you at least till the single-user test how it works. And then I point you to the regarding white paper, and then you can do that on your own. And then the perf timer is some cool little troubleshooting tool, which we demo in probably a nutshell. Entity store, we implemented an incremental sync when it just, in the first, when it came out, it was just basically an on-demand sync, but now, yeah, now we basically work on an incremental sync for it. So it gets a little more lightweight. All right, let's talk a little bit about scalability data. So this is like what you see in the upper part, top left to right. This is basically the recent perf tests we did. So I'm showing you a little bit of internal data here. And I summarized them kind of a little bit what we have seen. So in response times. So how we do these tests, we actually, we measure the response time, and then we know, okay, posting an invoice takes that many seconds, that many seconds. I don't show you how long the invoice posting takes because it's so dependent on what features you use. But when I have 100 users, the scenarios we run is always the same. We run order to cash, procure to pay, and general ledger posting. So there's always the same scenarios, right? So we run that. Order to cash means the whole sales order flow, so create sales order, pick, pack, and post. Procure to pay means the whole procurement flow, so create a purchase order, and then basically receive, and confirm, receive, and so on, invoice. And GL, we basically create a journal and post it, create a journal and post it. And then in total, on the 100 user test, we created 7,500 lines. The AOS and the SQL were basically in a very, very, very mellow state, right? Like 10% utilization. Performance was great. What we do is we log on during these tests, and we do manual testing. We don't only rely on machines. We also try human testing. So that was all beautiful, all perfect. It was all in the same environment. So we had a SQL Azure P6, and then 4013 V2 AOS, which is like if you see all the X7 customers we have, it's probably 40-ish right now, probably another 20, 30, 40 to come very soon. Bigger and bigger customers coming. That's a very, very, I would say, yeah, it's actually one of the bigger environments. And most environments are actually way smaller than that right now. So it's like maybe a P1 or P2 SQL server. So a little bit beefy environment, so it handles 100 users with no problems. Then we ran the same thing again with 300 users, and we could see that there was like no measurable or feelable regression, like when you logged in. It was pretty much the same. Some invoice posting was like maybe 2 to 3 seconds, purchase order posting 2 seconds, line create in millisecond areas if you create a purchase or a journal line. All pretty good. Then on the 500 user run, that was the first time we've seen tiny little bit of regression, but it was very small. You could see that maybe the purchase orders which got posted instead of like 2 to 3 seconds take like 4 seconds, right? So it kind of started regressing a little bit, but if you would play with it and log in, it would still feel very responsive, and the user would, I think a user would still have fun with it, right? Then the AOS CPU and the SQL DTU were at like 40%. And then it's 800 users, so basically the environment couldn't handle the 800 users. It was entirely maxed out. It was like the AOS CPU was at 95%, the SQL DTU at 60%. If you look at the line information, that's sort of important because you see 100 users, well, that's 1/3 of 300. And we created about 3 times as many lines, right? So you don't see much regression. There's no regression in the volume. And then, okay, 500 users is a little less than double, but we still create like about 39,000 lines. So that fits kind of from what you would expect from a linear scaling. But then 800 users, 60,000 lines. So it still creates like lots and lots of more lines, but the performance was just not good anymore. It was just like users would have complained, and when I logged in, I could also feel, yeah, the system's not so great. The solution here would be obviously blunt and simple. Get a bigger SQL queue and get a few more AOS. But the point of the test was, I say, we test typically with one environment till failure. It's like when you're bodybuilding, right, and you bench. Well, then you go till failure. So you want to know how many repeats you can do of a certain weight. So that's the same that we do here in these tests. We just test till failure, essentially. So our failure point with this environment was like 800 users, where we say, OK, we can do very well till 500 users, and performance is good, life is good. 800 users, well, not so much. We would need to scale out and scale up. Let's focus a little bit on these tables below. Don't know if you probably can I zoom in here. Let's see. Yeah, that's probably better. So this is from our test environment. Yeah?
One small question. So for 800 user scenario, you said the best recommendation is to scale out and scale up SQL?
That's what we would have done, yes.
Yeah, and so is it just around SQL or everything else just gets?
No, the AOS was totally oversubscribed, right? The AOS was at 95% CPU. So I would rather scale the AOS before I would scale SQL in this case.
So basically, like, try to scale up the AOS?
I would have added 4 more AOS and then probably even a stronger SQL. But the SQL could have probably done the job after it was only at 60% DTU. So, yeah. So, but the AOS would have been a must-do. Yeah, so this is from our internal telemetry. So I can get basically, okay, how many real slow forms where have been there, like, and then how often have the forms be called, right? So, and this is basically very much down to the scenarios which you see we test all the time, right? After we do a lot of sales order processing, you will see a lot of sales regarded objects there. But if you now compare which forms are really slow, so this is in milliseconds, the average duration, you see, well, it's the EER, so entity relationship mapped format designer, was opened twice and took 22 seconds. And the subledger journal account entry took 15 seconds and was opened twice. So if you look at, OK, these are not very high frequent openings of anything, then if you see how many have been opened in total, then you see that that's very different relation, right? If you see there's like 332,000 or 330,000 of sales edit lines, which on average take 500 milliseconds, then you see actually, well, that's actually quite good performance, right? So if you just put it in relation and say, oh, well, wait a minute. On top, I see, so on the top form, on the left side, you see the real slow operations when you open forms. And down there, you see basically the amount of how often forms have opened and which forms have been the most frequented. And I think that's a good statistic to see, okay, the sales table in general is a little slow. We know that and we work on that continuously. But in general, you also need to see the sales table has been used 117,000 times. So, and performance, well, 2 seconds is not super snappy, but it's still like something like it's adequate. And then other things like sales create order, 200 milliseconds, sales table list page, 550 milliseconds. That's good times. Let's look a little bit on the other side here. I can also see, for example, very simply in our telemetry, slow versus total interactions. We can get a hell lot of data out of this. We have tons of Power BI reports on top of it. But I figured that just for a performance session, I just show these numbers and highlight them. And so you get a little bit of feel of how it actually performs nowadays. And also other things, and tell you also what we do to make it better. So again, interactions is different than opening a form. Interactions is basically any interaction on a form or a process. So it could be a menu item click, could be a button click, it could be a report, could be anything, right? So before we looked at forms, now we look at interactions. And here we look at, the, again, the map format designer. So that's the same than before. Hold on a sec. Let's tell you something which is not true. Yeah. Then the subledger journal account entry comes multiple times, multiple interactions with 7 seconds. So that is typically just one, by the way. If you see 3 lines like that, that means it all goes down to TMP summary ledger dimension account. So that's just 24 occurrences. That's not 3 times 24. So that is just, yeah, happened not 72 times, but only 24 times. Because you see it's like a call stack, essentially. So, but then if you see again, compare the other interaction, how they do on the sales table, posting profile, credit card, they're all in the sub-second area. They have all been done like 1,810,000 times. So you can see again, like the mass of operations is actually very fast. Let's look a little bit on the same thing in production. Let me zoom that for you. So same thing like before, slow versus total forms. And then we can see up on the top is the slow forms. And you see basically res availability view. OK, so there's some real slow process. And well, what are we doing when we look at this? Well, we file bugs and we follow up on these bugs, right? And then we basically send hotfixes out. So the beauty of having telemetry like that and a cloud version is that we often don't need to wait till you report the issue. We can just look at our telemetry, and I do that almost daily, and file bugs and make AX better. That's why it keeps getting better every 2 to 3 months, because we continuously follow up on our own things. So here I know, oh, I have an issue, the REST availability view, I need to look into what's happening there. And the project budget balances, we also need to follow up, obviously. But then if you look at the mass of operation which is happening, sys operation sandbox form is basically whenever we put something in the sandbox. So sandbox is for us a concept of preventing a process from timing out. So if you have a long-running operation, like an invoice, right, or something like that, which could take a few seconds, there's like a 60-second timeout or something like that for any of these operations. So what we do is essentially we put it in a sandbox, and then yeah, you see has been used 69,000 times. The average duration is 8 milliseconds. Dimension lookup dialog. So you see many of the system forms actually having been used many times. Obviously, what you see here is all the standard things. If you have only like AX7 is a new release and you have a small customer base, you don't see so many of these mass operations yet. Like in our benchmark tests, we really bombard the system with requests, right? In the in-market version, our users are just not sitting there and entering 5,000 sales lines a day. They just don't do that, right? So that's why you see all the kind of system background things here. You see they're all incredibly fast. And let's look a little bit over here. So we have on top the REST availability view. You see in total it's 40. Again, this is more like a call stack. So that tells me a little bit more where the issue is. So for project budget balances, to fix that, we need to look more like in the system-defined office button, need to follow the chain down. And on the REST availability view, we need to look a little bit on this form. So it's actually more 40 calls, and well, they took on average 68 seconds. And I said, this is like where we file bugs and then follow through and make it better. And then if you look at these things down here, you see again on average, on the event edit info, edit invoice, very often used, 368,000 times, average duration, 700 milliseconds. So you can see all the real frequented operations. That's what I want to highlight. Yeah? We have a few outliers. If you see like, oh, well, that's 40 or 1,000. But you compare this to like 368,000 individual usages of something that's kind of almost nothing, right? It's like maybe 0.5% or less, I don't know, 0.3%. So you can see how good that actually works, right? And how fast AX7 actually is. So I don't want to make marketing, and I cannot really compare to AX 2012 ever, because it's a completely different architecture, but it is way faster. And overall, on average, I feel it's faster. Yeah, so the scalability roadmap. So we have a tiny little bit an issue, which we got with thank you from the SQL Server team. Yeah, so what happened when we shipped actually is that they didn't enable global temp tables. So we had to create temp tables, which AX does a lot. Every insert record set creates a temp table. And then you can create temp tables, TempDB temp tables, over the AOT, right? So, so we heavily use global temp tables, but we didn't have that. So we had to use regular SQL tables, like temp tables when we shipped. And that is basically, yeah, that left us with a big scalability issue. Because suddenly the log I/O increases dramatically because you do like insert 500,000 rows into like regular table. And what happens then is that the transaction log of SQL needs to take care of that, right? If I insert 500,000 rows in a temp table, well, no problem, because that's a fire and forget, done, happy. But on the log I/O, on the SQL temp tables, when we use regular tables and I put 500,000 rows in there, well, the log write of SQL has to catch up. So they fixed that for us. They enabled global temp tables for us. And we work on taking that up in update 4. So it's a recent thing they did for us. We have some internal prototypes. This 500 user test is done with the old technology. It's on update 2. So so we think right now we are safe to like 500 users, pretty much, with a P6 and 4 the 13v2 AOS. So we think we are good. We were holding back on bigger requests so far. If someone came, oh, I have 2,000 users, I have 3,000 users, we were more like, well, let's wait a half a year or so. Or we got some on real beefy SQL queues, because if you get on a bigger SQL server, then you have much more log I/O capacity. So anyway, the issue is resolved. In update 4 will be shipped in about 3 months from now. And I think then we'll look for much, much bigger customers, because then we can almost limitlessly scale on SQL. We did another thing. The insert record set is now using SQL sequences, so it doesn't even create a temp table anymore. So the insert record set created always a temp table, inserted in the temp table, then copied from there in the regular table, and it did that for the rec ID. When after we have the rec ID is done by SQL sequences, we just say, oh, well, why do the interim step? So we shipped that in update 3. So that's also increasing the scalability of AX. And yeah, now the entity store incremental sync is what we're doing update 4, update 5. The proper incremental sync. So, all right. Performance troubleshooting and tools. So there's like about 3 tiers of troubleshooting. So, and we will have a demo in like 2 minutes from now, probably. So I'll walk you through all of these steps. And essentially why I put this slide is just to show you like a little bit an overview and give you like a timeline. what do I do when, right? So what do I do if I just have an issue right now? So there's about 3 tools you can use. The one is, well, there's maybe a few more, perf timer. You just type "debug equals develop" in the address, and basically you can use perf timer to figure out what's going on there right now. Then you have the F12 menu of Edge or Chrome. Both are very, very similar. Shame on me, I'm going to demo with Chrome today. Sorry about that. And then Fiddler works again, very, very similar. Then, yeah, a little bit like the F12 menus and network recording. Then if the issue happens 4 weeks, 8 weeks later, and we talk a little more in detail how that works in a session tomorrow, we can still troubleshoot via LCS. You can still troubleshoot via LCS. And we go into that in great detail. So user reports an issue, says, well, this and this and this happened. So you don't need to right away ask him for a repo. You can actually go into LCS and figure a few things out there. And then if you have a repro, and if you really cannot figure anything out right away or with LCS, we still have trace parser. And I'm going to show you the things which change there too. So, right, that's what we're going to do right now. And so here we have X, beautiful and shiny. Let's assume I just have some slow process. I just want to understand. I show you the basic way. Yeah. Oh, oops. Let us stop the presentation. And here. Yeah, that should work. So let's just say I want to see, OK, what's going on in the back while I open, well, let's say, the sales order form. And I'll explain you a few things about the new architecture while we look at that, right? So you see this network tab, and the Edge network tab works pretty much very, very similar. It's just like, yeah, it's just showing you a bunch of process messages, sales table list page, so that's what I just opened, more process messages. So process messages is a new round trip. So whenever I send something to the server and ask him to do something, that's a process message. Then here I send a process message, request the sales table list page. You can also see a little bit on the URL what it does. And it sends me a static version of the sales table list page back. So we start pre-rendering already, actually. And then once the dynamic context comes, we basically fill that up. Let me just, how do I go in this presentation mode? Oh, forgot that. Anyway, let's hope I don't get too many messages. Let me close that. But that's all what beautiful Windows does, right? I know there's a presentation mode somewhere, but I forgot. And let's keep going. Yeah, and then on process messages, you can basically get a few values here. You can click here, and you can see the timing. And you see here, waiting time to first byte. So that is the actual server time, the time to first byte. So this time till the server can return the first byte on your request, right? And then the other component to the full round trip time is latency. So if we just wait long enough, AX will do a ping here. And then this ping basically is anything between, let's say, yeah, 50 and 60 milliseconds. Yeah. So then that adds up to your round trip time. So here we have a ping. And basically, you can see how long the ping in total takes. So technically, my round trip time was longer than the server time. So if I have time to first byte, is that right? You need to see how long the ping takes. So let me explain that right. So the time to first byte is inclusive. So now if the ping time takes a long time, then that means I had a really high latency at this moment when the ping happened. So let's say your time to first byte is 700. Maybe here we have a little bit longer, yeah, so 324. And now I see my ping taking 174 milliseconds, and my technical latency right now could be 74, right? So, all right. So the F12 menu can give you lots of little information of how long your round trip took. Is your problem on the server? Is your problem on the client? Can give you a feel for what's happening, right? There's another menu here, which is the console, which can give you some information when you run in debug mode. But for performance tuning, I personally prefer what I show you next. And that is so now we access X in debug mode. Now you see this timer here. That's the perf timer. So I click somewhere, it's updating. I see, oh, 2.8 seconds, 2.08 seconds. So what was going on? And I see, oh, navigation action server. I can see all kinds of times here. I can see the history, change selected index. I can see basically what happened on the client. And I can see, OK, what were the server performance counters? So what was going on here? And I can see the server calls. Now we see, oh, navigation action, 1.32 seconds. Now what was in this navigation action? I see, OK, command interaction, task, navigation action. So that took me the most time here. I can see the longest running SQL. And I could copy that to my management studio. And I could also basically just move. I can also see how many SQL queries I had in total and stuff like that. So very, very beneficial to essentially figure out, like, OK, did I have any long SQL call? You see, like, in an instant of SQL Server is the issue, right? So my longest SQL call was 72 milliseconds. Well, that's no problem, right? And then you have the total SQL execution time, 213 milliseconds. So I can see SQL was no problem. There was probably something in the server, something in the code doing it. So honestly, if I would have a performance problem here, let's assume that is the case. I just need to log in here really quick again, because otherwise we will not have so much demos later. Let me see, I should get a call. Let's keep going here while that happens. Yeah, there's no single sign-on anymore, right? We get phone calls every time we need to sign in somewhere. It's really cool. Beautiful new world. I really loved when I had my smart card and just, anyway. So yeah, so essentially it's basically a tool, cool little tool, which tells you in about half a second, hey, my problem is on SQL Server, it's on the server, or kind of it gives you a good direction, right? So you can do some troubleshooting and some stuff like that very easily with it. And yeah, so that's the perf timer. You access it, debug equals develop, and then you go from there. So anyway, what else? Perf timer, F12 menu. Fiddler. Well, I don't have Fiddler on this machine. But any one of you use Fiddler? Great tool. You can use it very much the same way. I prefer perf timer. Perf timer has some overhead. It will do a minor overhead on your operations. But it's a very good tool. And whatever you basically want to figure out really quick, you say, oh, yeah, OK, accounts payable, all vendors. You always see this little timer up here. You go in and see, oh, so what was going on here? Is it anything on SQL? And it keeps a history, by the way. That's also important to know. It keeps a history of things which were going on. I want to see, oh, what was this long thing here? And I can say, oh, was there any long SQL? So in this case, it's that guy, right? But total SQL execution time, 40 milliseconds. So, OK, nothing to look at. It's SQL sized. So a pretty nice little tool for tuning. OK, let's assume this thing failed, right? So I didn't find anything, or the user cannot remember. He just knows, oh, yeah, I did something. So here we are in LCS, in the environment monitoring. You access it the following way. You go in here and say, basically, on your environment overview, you just go into production, click on full details, and then click on environment monitoring here. It gets you to this page, and then you basically give her a UTC time here, and basically a time period, and then you basically look for, okay, what was going on at that point in time, and then you can filter here by activity. So I see basically all the things which were going on, and I can see, yeah, I can see basically all the servers here. I can switch servers on and off. I can say, well, I don't want to see this. I want to focus only on something else. And then my coworker who prepared this demo, Manali, she obviously did something, so I want to just filter everything down to what she did, right? If I don't click that, I just see generally which activities I spend the most time in. So I see quite some things here, but I want to just filter to her because she spent most of the time on this thing, besides the administrator. And then I see, oh, well, what was the real big slice here? So she did some ledger journal trans daily, ledger journal table processing. There was a big thing of other things she did. I can keep filtering down. And then we have the user activity here, which gives me a little bit information of what was going on in her session, what's the steps she did. And then let's say there was just some slow performance somewhere. I could always go from here in the raw logs. And once you access the raw logs, let's see if we can fix that. I can filter for, I want to highlight your attention just on these two for now. I can go for slow queries and slow interactions. So slow queries. And then I can just say, OK, let's go from 906. I just want to see some slow queries, right? And that shows me all the slow queries. So slow queries is basically what you had in AX 2012. The slow query form in AX, which basically you could say, oh, I want to log every query which takes more than 500 milliseconds. So we automatically log every query which is slower than 100 milliseconds, and it appears here. Now there's one thing to it. A query can be slow due to many reasons, right? What would be a reason for a query to be slow? Yeah, bad execution plan, index, but also the system is overloaded. So you need to check that, right? A query can be slow for many reasons. So just saying, oh, I have slow queries, and I just go after every slow query. No, you want to look in the time when the query ran, what did your system do? So, and this is very much how this whole thing here works. So you can look through that, and you can basically see where's the call stacks. And then you know, OK, my system is, the only thing you need to know additionally is maybe the execution plan, or if something was really slow here, if the system was overloaded. And we have the same thing for slow interactions. And we have a few other cool things like, that's the same thing. Everything more than 100 milliseconds, we basically log it. So you can see, OK, in the time where the user complained, these were the slow interactions. So it gives you like a little bit an entry point. And it gives you some form names and control names to go after. So you're not blind anymore. You can actually, like, even if the issue is like 4 weeks back. See, the data I'm looking at, well, it's like 3 weeks back, right? You can still figure out what was happening. So I think it's pretty cool because in AX 2012, well, whenever you came on the scene, right, the issue was gone. Here, you can still see what was happening. You can get some indications. You can also see, for example, if we talk about slow batch jobs, is batch throttled? So you can see if any of the batch jobs was throttled. You can see if AX actually crashed. Yeah, we are honest. We tell you if we crash. You can see deadlocks, if deadlocks happened. So pretty useful, I think. Oops, go forward. Yeah. And what I want to show you besides that is the environment monitoring. We said, hey, to understand, and I focus not on this overall monitoring, to understand if, for example, a query was slow because of resource consumption, we need to go in here and we need to look at, okay, the health monitors particular, and need to see, okay, on the SQL side, obviously after this is just a demo system, there will be almost never load on it. But I can go here through these system variables and I can see, oh, was there anything slow? Was my system overloaded? The SQL is not yet really set up very well. So mostly you can use the DTU consumption here. If that isn't 100%, this thing here, then you may want to look. If there was 100% DTU usage, then SQL Server had trouble, right? Here the DTU usage is like close to 0, so obviously that's not an issue. Just giving you some ideas. So SQL utilization tells you what will the SQL do, and if that was high and your query is slow, well, then you should rather look why was SQL so busy, right? And now we come to the next point, which is essentially our SQL Insights story. And here I see all slow queries in the time frame I search. So the same thing, you give a UTC time, and then you can see, oh, okay, in this time frame, this was the slowest query. And then basically you can download the query plan here, you can see the query, and you can see a trend. So you can see how the query has been performing over time. You can download these timestamps also in a CSV and can just basically build your own statistics on it. You may ask the question, why did we not just expose Query Store? Well, if your platform as a service, well, yeah, you have to take care of your platform, right? So we unfortunately can't. But we felt, okay, it's such an important thing in the AX to be able to tune efficient. So essentially we we implemented all that. So yeah. And yeah. So yeah, basically a cool little tool to understand what was going on, get the queries, get the plans, start tuning. Then the index analysis is here. So you basically can also look at the most frequented indexes. So you can go down here and can say, oh, well, what index was mostly used? What is the 15-day trend? And you can get the table metrics, which tells you the indexes itself. And then you see user scans, user seeks, user updates, and the total size. So you can also get like, okay, how big is the table? How big are the indexes? So it can tell you very quickly something like about the size distribution, right? So my table, the accounting distribution table, is the biggest table in my system, obviously. Maybe I need to do something about it at some point in time. Then the retail transaction sales trans is also pretty big. So you can get a quick information about why is your system data growing very quick. So you can figure a lot of things out with looking at index statistics. A, do I have many user scans? Why do I have all these user scans? Maybe I miss an index, right? B, okay, do I have maybe a table which is growing exponentially or an index which is growing exponentially? Maybe I need to do something about it, right? That's another thing. I can find the row log wait time here. So I can historically see which table has the biggest locking. Well, it's a demo system, so it's the table batch job. Well, in a production system, you see a different thing here, obviously. Then, yeah, on the performance metrics, we have the same thing. So we have different things here, like the duration in milliseconds, the logical I/O, the CPU time in milliseconds. So before we used the CPU sample, so let's say the DTU was high. The DTU can be high because of the logical I/O or because of CPU time. So we said, yeah, okay. Maybe this guy contributed to the most CPU time, so let's look what this query is. Pick it up, tune it, right? And then let's stay with the sample. I have high CPU time, but I want to find the query which contributed most. So there's two ways to it. Obviously, I can look at the query which took the most CPU time, but I also can look at the query which was executed the most, right? So this query here was executed 140,000 times. So then I want to know, okay, what query was that? Well, it's just cache flush. I say it's a demo system. But it tells me essentially that I can, with seeing statistics like that, I can very quickly find out, oh, wait a minute, okay, I had 100% DTU. Which query executed the most? Maybe I can tune something in my code there, right? And this is maybe not a slow query because it just is a very fast query. And then the other thing might be, okay, which query took the most CPU time? So maybe that contributed, or which took the most logical I/O, and so on. So a few tools to really quickly see what's going on. SQL Now is the last thing I want to show you in this little demo here. It essentially is, yeah, you see the current active statement. So that is, again, a thing where the user calls you and you just log into LCS. He says, hey, everything is slow, nothing works. Then you can see, OK, what are the statements which are currently running? Is there any blocking statements here? Well, right now, nothing's happening on this system, right? You can always refresh that and see if something's going on. So, and then basically, this is like more just-in-time tool. So we talk now about just-in-time first, and then about what can you do up to like 4 to 8 weeks later. So most of these things work well 4 weeks later. Then that has to do with how long we store the data. Most of the data is stored only for 4 weeks. Then we basically drop that. And then, again, a little bit about what can you do just in time. So the last but not least tool, I will not show you huge things about Trace Parser because it's in the market for a long time. But I show you really quick how you would use it. So first of all, if you want to trace a specific scenario and you cannot reproduce it with your admin account, then you need to go into System Administration and Users. And then you go to the user, and then you assign the role of systrace user. System tracing user, right? So now if Alicia would log in, she could actually take a trace. Otherwise, only admins can take a trace. So now to take a trace, you go on this little thing here, click on trace, say, oh, test 1, 2, 3, start trace. And now you do whatever basically you think you need to do to reproduce the issue. I have Alicia do it. And then you say, OK, that was my trace. So I stop the trace. And now you have two options. Download trace, that deletes the trace on the server and sends it to your desktop, has a real nasty thing. It opens a second window. And if you have a pop-up blocker, you just lose the file. And need to disable the pop-up blocker and need to trace again. Or upload trace, which I prefer. That stores the trace online. And you can download it up to 7 days later. So then you return to the main menu. And you have the button Capture Traces. And then basically, I can just click here, and I can download my trace and can access it. Well, once you have the trace, Trace Parser is on any dev system in the folder perf SDK. So you go on. It's either like, if you're on a proper dev system, it's typically installed on, hold on. It's usually in C, and then so on my other demo machine, the perf SDK is not set up. That's why I cannot show you. But any of the dev deployments you have, Trace Parser and all these things are either pre-installed, or if they're not pre-installed for whatever reason, in the folder C, you have the perf SDK. And there you get the MSI file. So it's right there. And you go basically in here. And then you see, wait a second. It's, I think, in the folder. Scripts, I think, for whatever reason. Oh, wait. No, here it was auto installed. Sorry. Usually, as I said, if it's for whatever reason not in there, look for the Trace Parser MSI in here. It's in this folder. Yeah. And if it's not here, then it's in the basically in the service volume in the Perf SDK local direct, and then you find it over this way. So, well, and then it's pretty much like all trace parsers. So you basically open the trace. It collects every session. You click on import trace here, select a trace file. I opened one trace already, and I want to just show you some quick things. So all the things like SQL view is the same, X++ view is the same. It's all the same, basically, how you know it from AX 2012. But important to know is look at these process messages. That shows you the round trips. And very often in AX 2012, when you start debugging, you look round trip by round trip. So you may want to look, is there any slow process message? So that's just some trace I randomly took for the demo. I could just say here process messages. And I know, OK, was there any particular slow interaction, right? So that's often a good thing to start. And I say jump to non-aggregate view. And then I say, oh, jump to call tree. And I want to check out, is there something happening in this process message which I should know of? Like down here. Oops. Little hiccup. No. Come on. Yeah. Yeah, it is. And then you basically can start drilling down and see, OK, what was slow here? Grid navigation, and so on. And then it's pretty much the same system like before. If you go and show the aggregate, right, you remove that. Technically, you either look for exclusive time, inclusive time, the SQL view. This particular thing here has no SQL, but if I find anything where there's SQL time attached to it, any user session, then I would have my SQL tab here. Well, this is like, I don't know, there's something wrong with this session. And then you have the timeline view, which basically tells you, OK, from start to stop, you can basically zoom through this timeline and can look at events which happened. So that's a different view of like, it's more like a view of the log. So trace parser collects all the event logs more or less which we emit. So you can also look at the logs in trace parser in this time. So that's also a little bit of benefit. So you can go through these logs and can say, hey, what was happening in a certain amount of time. You can zoom in, zoom out. Yeah, let's go somewhere. Let's just go administrator. And you can see, I use that more for like if any error happened or something like that, and can maybe see, OK, what was going on here. It's a different way to look at the logs. But I think the most common use will be like in the past. You first look if there's any slow query in your trace. Then you look if there's any high exclusive time in X++. So that's how I go. If there's query calls or select statements, then I go for that, look at that first. If there's some X++ expensives, then I go first by total exclusive. If that is really not cutting it, that's really not what I see, then I start by inclusive, and I start going down here and look at patterns, basically, and see, do I have multiplication patterns? Like I see 1 call, 100 calls. Well, that's a while loop, right? Or I see 1 call, 10 calls, which could be like a bad method where I just call the same thing again and again. Or it could be a recursion. So that's a little bit about the tools. SA Trace Parser is a pretty old school tool, so we don't need to go too much into detail about it. But I think the other time things, I think it was good to spend more time on it. All right, let's go back. Last but not least, AX7 load testing. So we want you to do your own load tests. Yes, and that's why we invested quite a bit in it. And we want it to be much, much better than in the past. Who did AX 2012 load tests? Well, no one. Yeah. Was it good? Had fun? No, probably not. Yeah. Once it worked, maybe you had some. Right. No, it's I feel it was quite tedious, to be honest. So what we do now is basically we just record scenarios, and then we have a tool to generate the code for the scenarios. And then you need to do actually almost no change to make it a single user test. It's literally like how you record it is how you use it. If you want to do a multi-user test, you need to add things like think time and stuff like that. And we have a pretty elaborate documentation. And then we basically have you generate the data. You need to somehow generate the load test data. And then you basically run the load test, and for that we use Visual Studio Online. So you have a lot of execution minutes free on Visual Studio Online, so there should be kind of no cost, unless you go into a crazy test cycle where you do thousands and hundreds of thousands of test hours or minutes. I think they charge in minutes, but they give you like a few 100,000 minutes. So that's kind of compared how it worked in the past. Well, we were on premise, we had a lab, there was a lot of metal, and now basically then we had the second step for us was, okay, AX is in the cloud, so we just have an endpoint, right? And we just point to the endpoint and fire. And we had still controller and agents on premise. And now basically what we currently use is just we have Visual Studio Online, and we send basically a load test from there to the endpoint. And how to create such a test? That is basically with the Perf SDK. The Perf SDK gives you all the tools to do that. And if you want to understand that in full detail, end to end, search in any search engine of your choice. For Perf 103. And you will see Introduction to the Perf SDK and Multi-User Testing. So that will tell you how to create a proper multi-user test. It takes a little bit to go through this lab. It takes like, it's quite some steps. 30 minutes is maybe a little optimistic. I think it's maybe like 2 hours, 3 hours. Because most of the time you will have to set up the Perf SDK a little bit. You have to set a test route. You have to copy things around. You have to install Selenium and so on and so on. There's like lots of things you have to do. So 30 minutes is a little optimistic, I guess. I should update that. So, but now to the demo. How do you actually create the very fundament of this multi-user test? So we go in here. We go to the start page. Let's say I just say task recorder. Oh, again. Sorry, that's my bad. And thank you. So I show you that again. So Perf 103, this is the lab down here. So just search for Perf 103, and then in the AX help, and you'll get there. And it takes you through this whole process. So now I want to create like a single user test, right? So the fundament of a multi-user test is a bunch of single user tests. For that, I create a new recording. I say my test. Click start. And what I did before is just said I open the sales order form. So I go to the root form, say accounts receivable, say all sales orders, click on the sales order. And you see it's nice and saves all these steps. Now I have 2 failures in my test, which I would need to handle in my code. I have 2 navigations. So I have a cleaner one. So you basically, a little tip for creating these tests, you always want to start on the start page, actually. You always want to start here and then go from there. And when you are here, you want to start your recording. That will save you a lot of hassle. So you go in here, and then only then you start your recording. But you see it keeps writing and keeps doing basically, OK, all of that. Then I click on stop, and then I say save as developer recording. That gives me an XML file. So I copy that XML file. And what I did before was this XML file. So open sales order 2.xml. And basically, then I copy that to my dev machine where I have this Perf SDK. And now I need to change the resolution. That's a nice little thing here. I need to do this for the test to work. Otherwise, Internet Explorer throws an error, says, hey, I'm supposed to be in 100%, but I'm in 200%, which is like an issue with the test framework. So that's why I had to do that. There you go here. Everything becomes horribly small. So yeah, how do I show that to you now? Essentially, hold on, let me change the resolution one more time, and only when we execute the test we change it. Otherwise, that's really not good. Say 200. It's a little better. So essentially, you go to Dynamics AX, and then you go to add-ins and create C# perf test from recording. And then you basically point to your recording, which, if you want a sample, the perf SDK has a sample. So I have it on the desktop. I say open SO2. I have done it already to be a little faster as a demo. Then you click on the project path, and the project path is basically, if you just want a sample which very quickly will work, you go to the perf SDK, and you go to the sample project, and you just saw perf SDK sample. And it gives you something to start off with. And then you go perf SDK path. And then, yeah, we're good. And then we'll click import. And then it ends up in the generated here. And then I have like my tests here. And then, well, now to run the tests, I need to actually do this screen resolution change. And, oops. Okay. And now I just right click here and say run selected test. And now you'll basically see how magic happens. Suddenly a browser window goes up and it just does all these steps. So if you do a multi-user test, you obviously don't see a browser window. It's doing everything over Visual Studio Online. It's just sending load to the endpoint. At the end, you get a report. But here you basically see this browser window opening. And you see how it is executing all the steps I did, which was essentially looking up a sales order. So it's opening that. So now this helps you to create single and multi-user tests, and it helps you to do repeatable testing. Because in the past, when you did any testing and you didn't have automation, you had to code in things again and again and again. Now you do the test case once, and unless your layout doesn't change a lot, you can just reuse the same test case again and again and again. Yeah, you see it's just opening a sales order, and then very soon the whole thing will be done. It uses the one on the box.
So you basically run the test automations from the AUS box.
From the dev box. So you cannot run that anywhere else but in your dev box. The single user test can only run on your dev machine. If you talk about multi-user testing, then you have basically a configuration, right? And that's all in this perf 103. So there's like this test.config or web. It's in the document, right? So, and basically there you point to which is your actual front end. So if you do a multi-user test, you need to point to an AX endpoint. But if you do a single user test, it always assumes basically it's right there. And it's also in the config. You can change it here too. The config is in there.
So in the past, we used Visual Studio to do the load testing, but for 2012, we had a lot of challenges with it.
Mm-hmm.
And we used this like German company AX Acceptance.
Mm-hmm. Acceptance.
But it was pretty expensive, so we used Visual Studio for like load testing.
Yeah.
The challenge was their like screen resolution and all these controls that basically are like really floating. So Visual Studio, that we tested, really goes to the coordinates. And if something changes in the interface, it fails. With this approach, basically, it's not linked to coordinates. It looks for this control names, field names, right?
Mm-hmm.
So we are not so that are we still dependent, or are we not dependent on physical layout of AX ports while running this test automation tool?
No, you are dependent. So with the task recording, you're actually dependent on the element being there. So
So if it's there, the student finds it, no matter where exactly it is placed before.
we can look at the code. That should answer your question. And that was, by the way, anyway, the last demo. So that was a great start of the Q&A part of the session. So if we go in here, when it's done rearranging itself, we maybe can, no, come on. So it basically, from the XML file, it generates these references. So it basically looks for these references. So the position itself doesn't matter. So it creates direct references to the regarding objects. So, and then it says here, sales table list page form. So you see grid, select record, change row in cache. So it basically, from the recording, it has methods it knows it needs to call. And it's compatible with pretty much most forms. That was all work items actually the task recorder itself did. So we just basically use that for our test framework.
Do you also use the schema testing framework to generate the initial data?
Sometimes, yeah, so the question is, do we also use this test framework to generate initial data? Sometimes we do that. Sometimes we use also a tool called DET. We had DET in AX7. We decided to take it out because it needs some more work to be really good. And we don't want to have things there which are not really good. So far, yeah, probably the best way is to just run this tool to generate your data, yeah. All right. Yeah. Any questions?
Can we link it to Test Manager?
Link to Test Manager? I don't understand that question.
So for instance, like in the past we had Test Manager to actually, document and help us to control their test process.
Uh-huh.
Not really connected to Visual Studio, it was probably more like a manual thing. But I heard that it's possible to use VSO and somehow Test Manager to create this library of like test scripts and basically like run them automatically. Or is it just done?
Yeah, it doesn't work automated yet, no. So you have an old school load test, and then you basically deploy it to Visual Studio Online. So right now you still use an old school VSTS test to set up and configure your test. So, yeah, any questions? Yeah?
So let's say I run into a blocking scenario,
Mm-hmm.
and I go and identify where the block is.
Mm-hmm.
What do I do with that?
So one of the features which come is that you can do some minor tuning things. So the question is, okay, what if I run a blocking scenario, I identify what query is blocking, I kind of more or less know what to do, but how do I troubleshoot it, right? So obviously, if it requires coding to fix that, you need to follow the regular deployment chain, which means you do the change in your dev system, then you deploy to Sandbox, you test your change, and then you ask our service engineers to deploy it to production for you.
No, but I mean more of this scenario where somebody's posting in your whatever, and for some reason something in that coding has basically been hung up, and it's blocking
I know.
15 other things that are
I
happening.
know.
And in the old days, we'd go in, identify it.
Yes. Let me tell you. So there is no way of handling that exactly right now, but we create a feature. So basically, so I talked about, okay, the one way is, well, if it's a fix in code, well, I can deploy it. That takes a few hours, maybe a few days. But there is some troubleshooting things you would want to do in SQL Server, which is like very quick things, like I want to kill a spit. Because as you say, the spit is just blocking everyone, right? And I have no other way of relieving all the other users but killing that spit, right? So, and there's other things. I maybe just want to update statistics on a table to see if the execution plan gets better. So this feature, unfortunately, right now is not in LCS, but this feature is planned to be in LCS. I cannot say if it'll land in update 4 or 5, but essentially what it is it allows you to do things like kill a certain spit. It allows you, so you would look at the SQL Now tab, which you have seen before, and you would identify a spit, and then you would use this kill spit feature. And it will be just a button and like a form. You say kill spit number, boom, right?
And in the meantime, it would be something where we could just open up a support ticket.
Honestly, that would be a pretty yeah, that would be almost a crit set because it could block many, many users. So you would open a ticket and then the DSE would do it for you, right? And that would also go like probably in half an hour. But that's not as fast as you want it to be. You want to do these minor things by yourself. So we said, create an index in the AOT, kill a spit, update statistics, do an DBCC free proc cache, these like minor things you sometimes need to do for troubleshooting, actually want to enable them from the LCS side. So that feature is in the feature backlog we have. Due to many, many other work items, we just didn't get to it yet. So we enable that, and we know about it, and we want to make it happen. Yeah. All right. Time is also out. I mean, if you have more questions, if you want to have a discussion.
One very interesting question. So I noticed that Microsoft guys use mostly Android and mostly Chrome. Does it mean it's better from performance perspective, or like more stable? Or?
So I can tell you why I use Chrome. I use Chrome for one reason. So I tested X with Firefox, with IE, with Edge, and with Chrome when we created it and deployed it. I personally use Chrome because I got so used to it, because there was a long time between IE and Edge in my mind till Edge was really good. Now I feel Edge is actually pretty good in its current state. But the first beta versions, they made us like dog food, were unfortunately not so workable in my mind. I mean, now I feel it's pretty good. But I just got so used to Chrome and I have it on any machine. So that's like, well, and I'm just a human being. I'm also a Microsoft employee, right? So it's personal preference. So in that sense, if you have other questions, let's meet up here. Let's have a chat. And otherwise, I wish you a great rest of the conference.